Okay, so we just want to do I want to do one example to demonstrate modeling using our calculator to make sure we're comfortable with the calculator for one, and to get a better understanding of modeling and how it can be a very powerful tool, but also the risks that go along with it. So we're going to use our calculator with this data that we have about First Virginia banks from 1990 to 1998, and we're going to find a least squares regression line, plot the data in the same viewing window, and then estimate the assets in 2010. So if we take out our calculator, and where we want to put the data in is in what we call stat, and then we're going to do edit, and then we get these lists. So now if there's already something in your list, so if I just type in some numbers here real quick, and you need to clear those, you want to highlight the list. So I have L1 highlighted, I hit clear, and then as soon as I go back down into the list, now that list is clear. Okay, so now we're going to actually put the data in. Now here we have to make a conscious decision. What do we want to use for the years? Do I want to use the full year, 1990, 1991, 1992, and so on? Do I want to just use 90, 91, 92, 93, and so on? Do I want to call 1990 0? That's another option. For the most part, all of those would be correct. However, it is going to give you a different regression equation, so you need to be conscious about what decision you choose. There are a few instances where using 0 is going to be a bad idea. So in this case, I'm going to use 90, 91, 92, and so on. So go ahead and put the data in. So I'm going to put in the years, and then we'll do our linear regression. Okay, so now you can see I have the years in, so now I'm going to go to list 2, and I'm going to start to put in the dollar amounts, understanding again that they're in millions, so I'm going to leave them that way. So 5384.2, and so on. Now I'm going to pause the recording so you don't have to watch me do all of this. Okay, so now I have all of the dollars in as well. Alright, now we need to do the linear regression. Now, before we do the linear regression though, there's one thing I want us to do on our calculator, and for this particular problem it's actually not going to make a difference, but I just want to point it out because if you take statistics or just understanding statistics, it will help us. So we're going to go into the catalog, so I'm going to do second catalog, and then I'm going to hit, see this is D here, I want to go down to diagnostics, so I'm going to hit D, and then we're going to scroll down until we find diagnostics, and I have diagnostic off and diagnostic on. I want to turn the diagnostics on. Now this might already be done on your calculator, it depends on if you've lent it out to someone who is in statistics or not, or maybe in another class you've used this. But just to be sure that everyone's on the same page, I'm going to hit enter, and then hit enter, so done. Okay, great. Now let's do the linear regression. So I'm going to hit stat, calc, and then I can see the fourth choice here is linreg, and then it shows ax plus b, that's our slope-intercept form of the equation of a line. So I'm going to hit 4, and now we're going to choose list 1, so I do second L1, comma, list 2, second L2, and now I also want this to graph for me. So to make that easy on myself, I'm going to do comma, and then I'm going to hit vars, and then I'm going to go to yvars, and then I want this to be a function, and I'm going to put this into y1. So I hit enter. Okay, now I'm going to hit enter, and it gave me this equation. Okay, so this gives me the equation of the line. So I'm going to move this over here so I can still see it, but I'm going to write my least squares regression equation, and so that's going to be y equals, I need the calculator to see that again, 489.575 x plus, or actually I think it was a minus because it was a negative. So let's look at that number again. So it's going to be minus 38,433. So minus 38,433.35. So if I show all of this together, y equals and so that's my equation of a line. So that is the least squares regression equation. Now real quick, what the diagnostics did is it gave us this r squared and this r value, which again, if you take a statistics course, you'll learn exactly what they mean, but just to kind of give us a helpful hint on what they're telling us is the closer this r value is to either 1 or -1, it has to be a value between -1 and 1, the better, that's telling us the better this line fits the data. So since this is really close to 1, that tells us that this is a pretty good fit. Okay, so we found our least squares regression equation. Now we want to plot the data and the model in the same viewing window. So that's where the fact that I already put the function into y1 is going to help. So that's why if I click on y equals, I should already see that function in y1. That was what I was doing when I did the linear regression. Now we also want to turn on the plot. So what we're going to do is we're going to do second y equals, and I'm going to do 1. I want to turn plot 1 on, and the type, this right here is scatter plot. The x list is list 1, the y list is list 2. That's good. So now if I do zoom and stat, which should be 9, but I'll just show you that. So if I scroll down, so zoom stat is the 9th choice. I hit enter. So now it plots those points, and it shows and it's graphing that equation in y1. So that's that part B here. Now for part C, we want to estimate the assets in 2010. Well, how can I do that? Well, I have this equation. So if I understand from this equation, well, what does x equal, or what does x represent, and what does y represent? So remember, x represents time in years. However, remember 90 corresponds to 1990. So what's going to correspond to 2010? Well, if 90 corresponds to 1990, then 100 would correspond to 2000. So 110 is going to correspond to 2010. Also, I want to make sure I understand y is assets in millions of dollars. So I'm just going to use my calculator now. I can go back here. I can use either the table function or the graph. In this case, I'm going to use the table because I think that's going to be a little bit easier for me. If I go to second table, okay, I don't want it in this mode. I'm going to change my table. So again, this is another helpful hint on the calculator. If I go to second window, which is table set, I want to change the independent variable to ask. What that's going to do is that's going to allow me to type in whatever x value I want into the table. So now notice when I go to the table, it's blank, and I'm going to type in, what did we say, x needs to be 110. So that gives me my y value of 15420. So again, answer in a sentence explaining what that exactly told us. Just want to double check, make sure I wrote that correctly. Yes, okay. So now, real quick, a couple of other things to say. So, what we did there was called extrapolating, and extrapolating can be kind of dangerous because if you think about, we have data from we know what's happened since '98 as far as the economy and banks and a lot of things. So we have data through the early and mid to late 90s when things were doing very well, and we're using that data to try to predict what's going to happen in 2010. So we want to take this answer, our $15,420 million, with caution, understanding that there are a lot of other circumstances that could change or that could make this data very incorrect. This model that we found should be very, very accurate within these years. However, outside of those years, who knows? It is still useful to help us try to predict things, but we want to be careful whenever we extrapolate.